Okay, so this is a video of the solutions from your last test, the test on chapter 2. Involves a lot of algebra, simplification of algebra, a little bit of factorization, etc, etc, etc. So the first question there, excuse me, write the following as a fraction in its simplest form. Probably what you notice is that this bit here is the difference of two squares, so that could be x plus 3 and x minus 3 and that'll be your denominator, plus, and underneath there you've got x minus 3. Now, one of the things that we had talked about in class is not to double up on your common denominators, because it just means that when you get to the end of the question you won't need to factorize anything else out. So you can see there that my denominator, I've just picked x plus 3 and x minus 3, so I haven't doubled up on the second x minus 3. So you pull the denominators together, and then bottom into bottom, drop down what's above. So if you take a look at what I'm doing here, I'm saying x minus 3 into all of this. Okay, so I'm just going to take this out. So I'm saying x minus 3 divided into what's below my new denominator, so that's x plus 3, x minus 3, so they'll cancel out. So there's my x plus 3, and drop down what's above, so the 3. So it's just 3 multiplied by x plus 3, plus, plus, and then bottom into bottom. So x squared minus 9 is actually x plus 3, x minus 3. So when I divide x squared minus 9 into my bottom, I actually just get 1 and drop down what's above. You're expected then just to tidy up the top line. You don't need to multiply out the bottom. So you'll have 3x plus 9 plus 2x tidied up, and you're finished. Okay. Next question. Factorize fully. So probably by looking at it, you can see that there's, well, the 9 and the 25. Well, they're perfect square numbers, so you're like, maybe the difference of two squares, but there is an x cubed in there, so that makes it a little bit awkward. Why not factorize out the x, and then what you're left with on the inside, the 9x squared minus 25, that's actually going to factorize nice and easily using the difference of two squares. So just being quite formal about it. So first plus second, first minus second, and don't forget to multiply the x on the front. So your next question, x to the 4 minus y to the 4. I suppose this is just one of those things. If you haven't seen it before, you're probably not going to be able to get it right. But power to a power means that you multiply. So I'm just going to change the way it looks, and that what I've got here is x squared. But forget about the fact that it's an x squared. It's something squared minus something squared. So that's actually the difference of two squares. So first plus second, first minus second. But don't forget here again, in the second part, you can see that's actually the difference of two squares as well. So it can be simplified a little bit further. Last question. Difference of two cubes. So it's x to be cubed minus 6 to be cubed. You can see over here on the right hand side, this is the little identity or formula that you need to learn. So x minus y all multiplied by x squared plus 2xy plus y squared, and the x and the y just represent your first and your second. So in this particular instance, x is represented by x, but y is represented with 6. So you can see I just popped that in there, tidied up a little bit, and I'm done. Okay, so that was your first page. Okay, so second page here. I'm going to take the x squared plus x minus 2, and I'm going to factorize it. So that will be here. I'm going to take what's below the line here, and I'm going to factorize it also. So that's x plus 3, x minus 1. It's still being multiplied by, you could use a dot, you don't have to put in the little multiplication symbol. What people tend to forget, just factorize out your 2 here, so that's going to give you 2 times x plus 3. And from underneath the line, don't forget to factorize out your 4. So that'll be 2 times x minus, that should be a 1 there. So let's just see, make sure I have this right. Your x plus 3 and your x plus 3 will go, your x minus 1 and your x minus 1, and you'll be left with 1 over 2 multiplied by, so you've got x plus 2 over x minus 1. Next question, part B. So for a question like this, just cover the answer there just for a second. You're having a look. What's causing you the problem, or the bit that you need to deal with first, is this x and this x underneath here. They're what's somewhat troublesome. So if you get rid of those, well then you've reduced the compound fraction just to a regular fraction. So what I can do here is I can multiply the top bit by x and I can multiply the bottom bit by x, because if you remember x over x, well that's still going to equal to 1. So technically I'm just multiplying the whole thing by 1. Don't forget though, the x on the top will need to multiply into both bits, and the x on the bottom will need to multiply into both bits. So you can see that happen here. If I multiply this, just put my x here, so x by 1 is x, x by 1 over x, well, that just gives me minus 1. X by 2 is 2x, x by 2 over x, well the x is cancelled, so that gives me 2. You're not quite finished, you can factorize out the 2 here, and then the x minus 1's cancel. And just a little bit, some of you were saying the answer was 2, remember, they cancel off, but it doesn't go to 0 or nothing, it doesn't just vanish, it's 1 and 1. Okay, so that's where the half, that's where the 1 on top is coming from. Okay. So binomial expansion. A fairly basic binomial expansion, but probably what the change that needs to be made for it is x plus 2 bracket minus 2y, close the bracket, 5. So this is essentially your x bit and this is essentially your y. If you remember, we said that it's NCR and the x's decrease and the y values increase. Just for the record, this isn't worth any marks in a state exams commission question. So I'm going to expand out the binomial, so you can see it there. 5 choose 0, 5 choose 1, 5 choose 2, 3, 4 and 5, so that's no problem. The x's are no problem as well, so x to the 5, 4, 3, 2, 1, don't forget your 0. Here this did seem to cause people a little bit of a spot of bother. So it's minus 2y all to the 0, minus 2y all to the 1, minus 2y all to the 2. Now that's worth a comment. Minus 2y all to the 2. Well, what that means is minus 2y multiplied by minus 2y, so that's going to be plus 4y. Now on top of that, I'm just going to fill in let's just talk about that again for a second. So your 5 choose 2, you've got your 5 choose 2, you've got your x cubed, and we've just discussed this goes to minus 4y squared. What happened for a lot of people is they actually dropped this bracket and they wrote their answer down as 5 choose 2, whatever it is, x cubed, and then they wrote down minus 4y squared. Okay? Whereas in actual fact you should have multiplied 5 choose 2 is 10, then you'd have your x cubed, that should be multiplied by minus plus, wasn't it? So that would have given you 40 x cubed y squared. So that was what seemed to be happening to people. They forgot that it was still being multiplied and they started adding like terms, etc., etc. The rest of it is fairly, it's just calculator work, and once you have that, once I've made that point, I think that's all I need to comment on it. Next question here. Show that that's a factor. So I've decided that I'm going to use division on this. I think I commented this for you during the class. So 4x squared plus 0x minus 1. It just means that everything will stay underneath everything else. So you're going to set up your division like so. So front into front. So 4x squared into 12x to the 4. There's your 3x squared. Multiply it back down 3 times. You are going to end up with some zeros here, but don't worry about it. Still 4x cubed minus 0x cubed is still 4x cubed. Work the rest of the question through all the way down and you're done. Okay, so the remainder is 0. Therefore 4x squared minus 1 is a factor. So moving on to the last page of the test. Quite poorly answered the back page of the test, so people definitely need a little bit of work on surds. You could simplify the root 80 and simplify the root 45 if that's what you wanted to do, but to be honest with you, there's actually no need. What you need to remember is, so root 80 plus the root of 45 all over the root of 80 minus the root of 45. To simplify surds, you multiply above and below by the surd conjugate. So that's root 80 minus 45, or the root of 45 I should say, root 80 minus the root of 45. Okay, you'll notice again that essentially is 1 over 1. So really what I'm multiplying by is actually 1. So I'm changing the way it looks, but I'm not changing its value. So you can see me do that here. It tidies up quite nicely. You end up here, works to 7. Next part of that question, again, fairly straightforward. I don't think there's anything too difficult about it. Notice the conjugate of the bottom. So it's root 7 minus root 2. So I'm going to multiply above and below by root 7 plus root 2, which is essentially 1. So I'm changing the way it looks, but I'm not changing its value. A little bit careful with my multiplication, it works out nicely. So 11 plus 3 root 14 all over 5. And you'll notice that this form here matches the way that I've been asked to answer the question. So the last part of the question then is this. Now this is, I suppose, somewhat worrying given that I've pointed it out several times in class. A lot of people realized a squared minus bc is equal to a minus b, and they squared it, which was great. And then a squared minus bc, what a lot of people decided to do was a squared minus b squared. That's a big no. So if you see a big no written beside your work, you know that that's the error that you made. So what should you have done? Well, square it out like so, or we've talked about that line there. So square both sides. It's the c that I want, so I'm going to bring this a squared across and subtract it. And then I see that maybe I can get some to cancel if I square out these brackets. So I didn't do that, sorry. I'll do that in a second. Minus b, divide both sides by minus b. So at least now I have c on my own. At this point I'm correct. Okay, I just want to try and simplify it a little bit further. So now I squared out my a minus b all squared. Let's see that here. So the a squareds, they'll cancel away for me, which is nice. And then just have a quick spot. There's actually a b and a b here that the b below will divide into, but this minus will change the signs on top. So you'll see that minus b into minus 2ab is 2a, and then minus b into plus b squared is minus b.